In this question, you will be exploring the number and nature of roots of cubic equations of the form x cubed plus ax squared plus bx plus c equals 0 using Cardano's method. Consider a cubic equation x cubed plus ax squared plus bx plus c equals 0 where a, b and c are real. Using the substitution x equals t take away a over 3, where t is real, show that the original cubic equation can be expressed in the depressed cubic form t cubed plus pt plus q equals 0 for p and q belonging to the reals. So note that this has no t squared term. So let's tackle this. Using the substitution, we have t take away a over 3 cubed plus a t take away a over 3 squared plus b t take away a over 3 plus c is equal to 0. Expanding out gives us t cubed take away at squared. Remember, we have the binomial coefficient 3, and then you would have t squared, and then the negative a over 3. So that's why those cancel. And then we would have a squared t on 3, take away a cubed on 27, plus a, expanding out the quadratic here, gives us t squared, take away 2at on 3, plus a squared on 9, plus bt take away ab on 3, that's expanding this out, plus c is equal to 0. So let's tidy that up, well, let's at least expand that bit. So that gives us t cubed plus a squared on 3t, take away 2a squared on 3t, plus bt plus c, take away ab on 3, plus a cubed on 9, take away a cubed on 27. So I've both expanded that out and tidied. For example, I've just noticed a mistake there. That's an at squared. And so that and that cancel out, for example. So I've done that tidying as well here. And so that would give us t cubed plus b minus a squared on 3t plus c minus ab on 3 plus 2a cubed on 27 equals 0. So we can spot from that p is equal to b minus a squared on 3, that being the coefficient of t here, and that q is equal to c plus 2a cubed minus 9ab on 27. That's just writing those two over the common denominator of 27. Now for part B. We're going to let t equal u plus v for uv belonging to reals, and u is greater than or equal to v. Show that u cubed plus v cubed plus u plus v times 3uv plus p plus q is equal to 0. So we have u plus v cubed plus p u plus v plus q is equal to 0. Now that is just putting in the u plus v into this equation up here. So u cubed plus 3u squared v plus 3uv squared plus v cubed plus pu plus pv plus q is equal to 0. So u cubed plus v cubed plus 3u squared v plus 3uv squared plus pu plus pv plus q is equal to 0. That is u cubed plus v cubed plus u plus v into 3uv plus p plus q is equal to 0. And that's what we were expected to show in part 1. Write down the value of u cubed v cubed for which u cubed plus v cubed is equal to negative q. So, negative q, just taking that onto the other side there. So, we need u plus v, 3uv plus p, to be equal to 0. Now, we were told up here that u is greater than or equal to v, but let's consider the case that u plus v is not 0. That implies the solution comes from 3uv is equal to negative p. So uv is equal to negative p on 3, which means u cubed v cubed is equal to negative p cubed on 27. Write down expressions for the sum and the product of the roots of the quadratic equation t squared plus qt take away p cubed on 27 is equal to 0. So, this is part 3. So we have t squared. Let's just check. That is t squared plus qt. Yep. So t squared plus qt take p cubed on 27 is equal to 0. Now, the sum of the roots then is going to be negative q, because it's this divided by this, or negative this divided by the coefficient here, which is just 1. And then alpha beta is equal to c over a, so that will be negative p cubed on 27. So what's part 4 ask? Hence show that if u cubed plus v cubed is negative q, then u cubed and v cubed are roots of the quadratic equation. That's the same equation that we had above. So, in part 4, we're given u cubed plus v cubed is equal to negative q. So, that means that u cubed v cubed would be equal to negative p cubed on 27. So these are the required roots. And of course, we know that from here. I didn't just come up with it out of thin air. Hence, find an expression for u cubed and an expression for v cubed in terms of p and q. So, Let's just make ourselves a bit more room. T would be equal to, just using the quadratic formula, negative q plus or minus the square root of q squared take away 4 times 1 times negative p cubed on 27 all over 2 times 1. So that is going to be negative q plus or minus the square root of q squared plus 4p cubed on 27 over 2. And so u cubed is one of the roots, negative q, plus the square root of q squared plus 4p cubed on 27 over 2. And v cubed will be the other root, negative q, take away the square root of q squared plus 4p cubed on 27 divided by 2. So we're now asked to consider the case of a cubic with the equation x cubed plus 6x squared plus 9x plus 4 equals 0. Show that the depressed cubic equation is t cubed minus 3t plus 2 equals 0. So following what we did before, x would be equal to t take away 6 on 3, which is t take away 2. So we have t minus 2 cubed plus 6t minus 2 squared plus 9t minus 2 plus 4 is equal to 0. So t cubed minus 6t squared plus 12t take 8 plus 6t squared minus 24t plus 24 plus 9t take away 18 plus 4 is equal to 0. And if we tidy that up, we do get t cubed minus 3t plus 2 is equal to 0. Show that u cubed and v cubed are roots of the quadratic equation t squared plus 2t plus 1 is 0. So, again, following results that we've had before, the u cubed plus v cubed here would be equal to negative 2. And the u cubed v cubed would be negative p cubed on 27. And that would be the negative of negative 3 cubed on 27, which is equal to 1. So the sum of the roots is negative 2, product of the roots is 1, gives us t squared plus 2t plus 1 is equal to 0. Find the value of u and the value of v. So for part 3, t would be equal to negative 2 plus or minus the square root of 4, take away 4 times 1 times 1. I'm not sure why I'm doing this actually, because doesn't that just factorize? Okay, that's how I did it the previous time, but anyway, that all comes to negative 1, as it would if we just factorize that into t plus 1 squared equals 0. That means that u cubed is equal to v cubed is equal to negative 1, and that's following from up here. And so u is equal to v is equal to negative 1. Okay, and then 4, using your calculator or otherwise, find the solutions of the cubic equation x cubed plus 6x squared plus 9x plus 4 equals 0. And we could do that on the calculator and we get x is equal to -4 and -1 twice. So what we have in that case is one repeated root and then another root, all of the roots being real. Now consider the case of a cubic with the equation x cubed plus 3x squared minus 3x minus 8 is 0. The depressed cubic equation is t cubed minus 6t minus 3 equals 0. Given that u cubed and v cubed are roots of the quadratic equation, t squared minus 3t plus 8 equals 0, explain why u and v belong to the complexes. So, if we consider t squared minus 3t plus 8 is equal to 0, v squared minus 4ac, the discriminant, is -3 squared, which is 9. Take away 4 times 1 times 8, which is -23. And therefore, the roots are complex. State whether the cubic equation x cubed plus 3x squared minus 3x minus 8 equals 0 has 3 real distinct roots or 2 complex roots with 1 real root. So we're just going to do a graph, and if we do that, you will see there are 3 distinct real roots.